Central tendency and dispersion introduces statistical tools used to summarize and analyze investment data. In finance, analysts frequently work with large datasets involving returns, interest rates, earnings, and economic indicators. Measures of central tendency help identify the typical or average value within a dataset, while measures of dispersion assess how spread out the observations are around the average. Together, these statistical concepts provide insight into both expected outcomes and the degree of variability or risk associated with investments. The topic emphasizes that understanding the distribution of financial data is essential for portfolio analysis, risk management, forecasting, and informed investment decision-making. The topic begins with measures of central tendency, including the arithmetic mean, geometric mean, harmonic mean, median, mode, and weighted mean. The arithmetic mean is calculated as the sum of observations divided by the number of observations and is commonly used to estimate expected returns over a single period. The geometric mean measures compounded growth over multiple periods and is especially useful for evaluating long-term investment performance. The harmonic mean is applied when averaging ratios or prices across equal monetary investments. The topic also explains that the median identifies the middle observation in an ordered dataset, while the mode represents the most frequently occurring value within a distribution. The topic highlights the strengths and limitations of each measure of central tendency. The arithmetic mean is easy to calculate and interpret, but may be distorted by extreme values or outliers. The geometric mean better reflects compound investment growth, but is typically lower than the arithmetic mean when returns vary over time. The harmonic mean is most appropriate for averaging costs or valuation multiples. The median is less sensitive to outliers and therefore useful when data distributions are skewed. The topic emphasizes that analysts must choose the most appropriate measure based on the characteristics of the dataset and the specific financial application being evaluated. The second major focus of the topic is dispersion, which measures the variability of observations around the central value. Dispersion is important in finance because greater variability generally implies greater uncertainty and investment risk. The range measures the difference between the highest and lowest observations, while the mean absolute deviation calculates the average distance from the mean. More commonly used are variance and standard deviation, which quantify how widely observations are dispersed around the average. Standard deviation is particularly important in investment analysis because it serves as a widely accepted measure of total portfolio risk and return volatility. The topic explains the distinction between population and sample statistics when calculating variance and standard deviation. Population formulas are used when the entire dataset is available, while sample formulas adjust for estimation bias when only a subset of observations is analyzed. The topic demonstrates that larger standard deviations indicate greater volatility and uncertainty, whereas smaller values suggest more stable returns. In investment management, standard deviation is widely used to compare the risk profiles of securities and portfolios. The topic also introduces concepts such as coefficient of variation, which standardizes risk relative to expected return and assists analysts in comparing investments with different average returns. Overall, topic establishes the statistical foundation necessary for quantitative financial analysis. Measures of central tendency help estimate expected returns and identify typical outcomes, while measures of dispersion quantify uncertainty and investment risk. These concepts support many advanced applications throughout the CFA program, including portfolio theory, asset pricing, risk management, and hypothesis testing. The topic emphasizes that financial analysts must not only estimate expected returns but also understand the variability surrounding those expectations. Mastery of central tendency and dispersion enables investment professionals to interpret financial data more effectively, evaluate risk-return trade-offs, and make more informed investment recommendations in increasingly complex financial markets.